All right, today we're going to talk about a drug that did more than just treat a disease. It completely rewrote the rulebook for how we fight cancer. This is a story about a single brilliant idea that changed everything. And the wild thing is, it all starts with something so simple. Something you can literally hold in the palm of your hand. A single daily pill. So what did this little pill do? Oh, not much. Just took a type of leukemia that was basically a death sentence and turned into a chronic, manageable illness. It gave hundreds of thousands of people their lives back. This, right here, is a story of Imatinib. To really get why this drug was such a mind-blowing revolution, you first have to understand the enemy it was up against, a cancer called chronic myeloid leukemia, or CML for short. Okay, so what is CML? Well, think of your bone marrow as the body's factory for blood cells. In CML, that factory goes completely haywire. It just starts churning out way too many white blood cells, and they eventually crowd out all the healthy cells your body actually needs to function. And I want to be really clear about this. Before the year 2001, getting a CML diagnosis was absolutely devastating. The outlook was grim, the treatments were harsh, and they often didn't work. That was just the reality for every single patient. But the big breakthrough didn't come from a stronger chemo or a new kind of radiation. Nope. It came from going deeper, from cracking the disease's genetic code and finding the exact on switch that was causing the whole problem. What scientists found was kind of bizarre. In CML patients, two of their chromosomes, number 9 and number 22, were literally swapping pieces of their DNA. This weird swap created a new, mutated, shorter chromosome 22 that they called the Philadelphia chromosome. Now, this was a huge deal because it was one of the first times ever that scientists could point to one specific, consistent genetic flaw and say, that right there is what's causing this specific cancer. So what does this genetic mix-up actually do? Well, it creates a totally new Frankenstein gene called BCR-ABL, and this gene is bad news. It produces a rogue protein, an enzyme that is always, constantly switched on. The best way to think about it is like having a car's accelerator pedal stuck to the floor. It's just relentlessly screaming at the bone marrow, make more white blood cells, more. That was it. That was the single engine driving this cancer. And here's the beautiful part. If you know the exact cause, you can design an exact solution. This is where the story shifts to just a masterpiece of molecular engineering, designing a magic bullet to hit that one single target. The target, that rogue enzyme, is what's known as a tyrosine kinase. You can think of these enzymes as the light switches for our cells. They turn things like cell growth on and off. The whole problem in CML is that the BCR-ABL light switch is broken and permanently jammed in the on position. So how does this magic bullet work? It's actually incredibly elegant. The drug, Imatinib, is designed to do one thing: hunt down that specific BCR-ABL protein. When it finds it, it plugs up the exact spot where the enzyme gets its fuel, a molecule called ATP. Without its fuel, the enzyme can't send its grow signal anymore. The switch is flipped off. And the cancer cells, they stop dividing and start to die. Simple as that. The best analogy, and you'll hear it all the time, is a key in a lock. The BCR-ABL enzyme is the lock. Imatinib is the perfect key, custom-made to slide right in and jam the mechanism so nothing else can get in. And this is what made it a completely new way of thinking about treatment. Traditional chemo is like a carpet bomb. It just destroys all fast-growing cells. The cancer, sure, but also your hair, your stomach lining, your immune cells. That's why the side effects are so brutal. Imatinib, though, is like a sniper. It takes out that one single protein that's causing all the trouble and leaves most of your healthy cells alone. And this wasn't just some cool theory that worked in a lab. When they tested it in the real world, the results were just astonishing. It truly kicked off a new era of cancer treatment. The big year was 2001. That's when the FDA gave it the green light, and that was the moment, right there, that CML officially went from being a fatal disease to a chronic, manageable condition for almost every patient. Just a massive turning point in medicine. What's really fascinating, though, is that the story didn't end with CML. It turned out that the luck Imatinib was built for, or ones that were very similar, were also driving other types of cancers. That's why it's also incredibly effective for things like rare stomach tumors called GIST, and even some types of acute leukemia. But here's the thing. Even a magic bullet isn't a magic pill that has zero consequences. For the thousands of people whose lives were saved, it also meant learning to live with the day-to-day realities of being on a long-term therapy. I mean, there are common side effects, things like swelling, muscle cramps, fatigue, and even though it's targeted, the drug can still cause serious problems, like messing with your blood counts or your liver. That's why anyone taking it has to be monitored by their doctor, constantly. It's absolutely crucial. Patients also have to be super careful about any other medicines they take. See, because of how the liver processes imatinib, some things, even a simple herbal supplement like St. John's wort, can actually make the drug weaker. And other things like certain antibiotics can ramp up its levels in your body to a toxic degree. And, as it always seems to, cancer fights back. Over time, some CML cells learn to mutate. They actually change the shape of the lock, that BCR-ABL protein, so that the imatinib key doesn't fit anymore. This is drug resistance, and it's what pushed scientists to create the second and third generation drugs to try and outsmart the cancer again. So, when you step back and look at the whole picture, what's the real legacy of this one pill? It's not just a drug. It was a full-blown revolution. This quote really just says it all. Imatinib isn't just another pill on the shelf. It's a true landmark, a turning point that proved an entirely new way of thinking about cancer was not just possible, but could be incredibly, profoundly effective. When you boil it all down, imatinib's legacy is this. It proved that the whole idea of precision medicine, of targeting the one specific thing driving a disease, actually worked. It took a deadly cancer and made it chronic. And it gave scientists the blueprint that has been used to create dozens of other targeted therapies since, completely changing the world of cancer research forever. And that leaves us with a really powerful and, I think, hopeful question. We know it can be done. The blueprint is there. The only question now is, with everything we've learned, what's the next disease that's going to go from being a devastating diagnosis to a manageable condition?